Welcome to the 2423 video on thin layer chromatography. I'm going to begin by talking about how we prepare the TLC plates for TLC analysis, which is somewhat important because you'll notice when you open up the boxes you're going to find lots of TLC plates in lots of different shapes and sizes, and that's not reproducible. So I'd really like people to follow this procedure for making their TLC plates. So we begin by obtaining one of the large TLC plates from the box in the laboratory, and they're just big, almost square, almost perfect squares, but not quite. They're a little bit longer on one side than the other. And so on one side you're going to find that the plate is almost exactly 20 centimeters long. And so if you take a ruler, here's the ruler, and measure, you're going to find 20 centimeters or 200 millimeters from top to bottom. And so you want to use the metric side of the ruler. And so we're going to divide this into thirds. And so about a third of 200 is pretty close to 67. So you're going to put a mark with a pencil, very important to use pencil on this, at 67 millimeters. And then twice that at about 134 millimeters. 34 millimeters. And you'll mark the other side of the TLC plate at the same spots, 67 and 134. And then you're going to use the pencil to draw a line to connect the spots. So there is one of the lines, and there's another. So we're going to cut down these lines with scissors. And that's going to give us three identical strips that are about 67 millimeters in width and close to 20 centimeters long. It doesn't really matter the length on this side. And so the next thing you're going to do is get a cutting board. And so here's our cutting board. And of course there's a little handle on one side of it. And you're going to take the strips that we just cut, one of the strips, and place it on the cutting board. And we're going to cut off the actual plate that we'll be using for analysis using a razor blade. And the width of these plates depends upon the number of spots that you intend to put on the plates. And so I recommend for each spot about 5, you'll be placing the spots. Let's see if I can do this down below here. So if this is the bottom of the TLC plate, let's say we're going to put 3 spots, which is about the maximum that I usually put on a TLC plate. So the first spot, I should have done this a little bit larger. Let's expand this a little bit. So this is going to be the very bottom of one of the TLC plates we're about to cut out. And so each spot should be about 5 millimeters. The first spot, that is, should be about 5 millimeters. And you're going to spot these with a pencil. You never use ink on these TLC plates because the ink will be moved with the solvent when we develop them. So the distance between the spots as well as the distance from the spots to the edges of the plates should be about 5 millimeters. So this distance right here, the first spot, right there, it's about 5 millimeters. And so the next spot should be about 5 millimeters from that one, so equidistant, and same thing with the third spot. And so each of these distances, again, is approximately 5 millimeters. And so 5 and 5 is 10, 15, 20. So, did I say, so if you're going to spot a plate with 3 spots, you want a width of about 20 millimeters here. And so we'll assume that's what we'll be doing on this one. And you can measure that with a pencil. You really don't have to. You can kind of eyeball that. And so we're going to take a razor blade now. It's important to use a razor blade here and not scissors, and I'll talk about that. So here's our razor blade. Be careful with the razor blade. And we're going to, now, there's two sides to these TLC plates. Okay, there's the side that contains the stationary phase, which is silica gel. That's the side you'll be spotting your compounds onto, your mixtures or your compounds. And then there's the backing to that, which is plastic. There are also glass TLC plates that you cut with glass cutters, but those are more expensive. We're not using those. We're using the plastic ones. So you're going to cut with the plastic face up. That's the smooth side of this. Okay, so you're cutting, this will be up, the plastic side will be facing upward. The silica gel, which is the rougher, kind of whiter side, is facing downward. And so you have to press kind of hard with a razor blade. If it doesn't cut well, you probably need a new razor blade, and you're going to do that and just pushing fairly hard. Just cut off the TLC plate like that, okay, to the width that we discussed down here. And so that's how you prepare the TLC plate for TLC analysis. And again, I'd like everyone to follow this procedure because this will give us the same size plates, or at least the same length plates. And if you have lots of different plates of lots of different lengths, then that affects your reproducibility. One more thing I should mention before I move on to the next topic, and that is why we're using a razor blade here instead of scissors. In my experience, if you cut these smaller strips off with scissors are fine to use here, although you want to be careful because what we're trying to do is avoid disturbing the silica gel. The silica gel is attached to the plastic backing, and if that comes off, that's what you're using to separate. It's the stationary phase used to separate your compounds. If the silica gel comes off, then that affects your results. So you're trying not to disturb the silica gel as much as possible when you're cutting these plates. And what I found is if you use scissors over here instead of a razor blade, that tends to give a less clean edge to this. And it can cause what I refer to as feathering, where you get little cracks in the silica gel on the side of the TLC plate here. They kind of look like just little tiny cracks. And what will happen if that occurs, if you disturb the silica gel on this side, as often occurs when you use scissors, when we develop these things, the solvent will not go up evenly, and that will affect the reproducibility in the TLC results. So that's the reason why we're using the razor blade here. That tends to minimize the disturbance of the silica gel on the side of the TLC plate. So the next topic I'm going to discuss is spotting the TLC plates. That is, we're going to learn how to load the sample, the solutions or the compounds that we're going to be separating by TLC onto the plate itself. And so I will draw an expanded model of the plate, magnified, and we'll do this for spotting two compounds. So we're going to use a pencil again, as I mentioned previously, for spotting the bottom, for putting spots on the bottom of the plate. And those spots are just guides for us to where we're going to actually spotting our sample solutions. And so recall, you're going to measure about 5 millimeters. You can kind of eyeball this. You don't have to do this with a ruler, from the edge of the TLC plate for the first spot. So I'm marking that with a pencil right there. And then for each spot, so again, we'll do this for 2 spots. For each spot, you want about 5 millimeters in between the spots. The reason we're giving that much room is that as the spots are pushed up the TLC plate by the solvent, they tend to expand a little bit. So we want to avoid them overlapping as we develop it, and we'll talk about that later. So just to go back over this one more time, 5 millimeters from the spot to the side of the TLC plate, so that's 5 millimeters. Another 5 millimeters between the spots, 5 millimeters. And from the bottom of the plate to the spot where you're marking with a pencil, I would give another 5 millimeters. So that's easy to remember. And the reason for that is it's going to be really important that when we put this in our developing jar, that the solvent that will be down at the base of this does not reach these spots. So we need to give a respectable amount of room between where we spot the TLC plates, the samples, and where the surface of the solvent is going to be in the jar. So So that's how we prepare the TLC plate for spotting. One of the things I like to do when spotting TLC plates, or to help me spot TLC plates, is I'll get either, well, normally in our laboratory we have these plastic weighing dishes, so they kind of, if you turn it upside down, it kind of has this shape. It's round on the bottom and kind of open and square on the top. So I've turned this upside down. So if you're looking at it upside down, you see kind of a round bottom, I believe. Is it round? I think it's round. It could be rectangular or square. Doesn't really matter. Actually, I'm going to make this a little bit bigger, make this easier to see. That's more like it. It's not to scale. And I'm going to take our razor blade again, and I'm going to cut some little X's into this, and I do one for each of the different samples that I'll be doing. So if you had 4 samples, you could cut 4 X's into the plastic. And I always put one in the center for the solvent that I'll be using to clean the capillary that we'll be using to spot the TLC plate. So we use really small test tubes to spot our samples, and they're literally about this size. And so I'm going to push those test tubes into the X's there, and that's going to hold them upright. So if you were to look side on, again, these weighing boats are turned upside down now, you would see the test tube pushed into, will be standing upright, and this just holds them up. It's just a holder for the test tubes, and of course your solutions are inside. So we're spotting 2 compounds onto this particular TLC plate. I'll call them compound A and compound B. There's one spot for each. So we've got A in this test tube, a solution of compound A in this test tube. And we'll have a solution of compound B in another one. So there is our solution of B. And in the center test tube, we'll have just pure acetone. Consistent with my colors here. So in that one, we've got acetone. And that's the solvent that we'll be using to, again, rinse out or clean out our capillary. So the next step here, we've got our solutions, we've got our sample holder, is to actually spot the plate itself. And I'm going to expand one more time the bottom part of the TLC plate here. That's this part right here. Over here. There's the pencil mark for the first spot, and there's the pencil mark for the second. So this one is for, again, compound A, and the solution containing compound B here. So you're going to take a clean capillary. If it's not clean, it's no big deal, because you can clean it out with the acetone. That's what that's for. And you're going to stick the capillary into the solution of compound A. So that's the capillary, a little thin glass tube. And that's going to draw the solution up in the capillary. You're going to take the capillary and spot the plate. I spot it right above the dot that we made with the pencil, right above the mark we made with the pencil right there. And so what you'll see at that point when you spot it is some of the solvent, some of the solution will come out and make a round dot here. And so that's about the size that you want. You let a little bit of the solution come out, then you take the capillary off and you let this solvent evaporate. Okay, and I do that 2 or 3 times. What you don't want to do is leave this on here so that you get a big spot. You want to keep these spots as small as possible. So you touch it, let a little run out, take the capillary back, let it evaporate, and then repeat that process about 2 or 3 times. So once you've done that, you're going to get the UV lamp. Okay, so here's the UV lamp. You put that over the TLC plate. And there are 2 kinds of UV that come out of these lamps, long wavelength and short wavelength. So you're going to use the short wavelength UV. There's a little slide that allows you to choose which one of those types of UV to use. So use the short wavelength UV. And so you shine the UV light onto the TLC plate, and what you should see here is a dark spot. So, dark spot right there. If it appears faint, then that means that your solution was not very concentrated, and that means you need to spot this more times until it becomes dark. Okay, so usually these solutions are concentrated enough that just tapping the capillary on here 2 or 3 times to let a little bit of solvent run out is enough. But sometimes that's not enough if the solutions aren't concentrated. So we'll assume that's what we're seeing right here. So we've spotted the first compound, or the first solution A, onto the plate, and then we repeat the procedure. But the first thing we have to do before we repeat the procedure is take the capillary and draw some solvent up into it, some of our acetone from the central test tube. And we're going to let the acetone run out onto a paper towel. And so we take the capillary and the solvent runs out onto this paper towel. And you do that about 3 times. That is enough to make certain that any residue of the first solution is out of the capillary tube. And then we take the capillary, draw up a sample of our second solution, and spot that as we did the first above the second dot. And so that's what you do for each spot that you add to the TLC plate. Just a couple more important points before I move on to the third and final part of the procedure here. The UV light here is short wavelength UV. That's fairly high energy light. That light can damage your eyes, it can sunburn you, so you want to avoid exposure and do not look at this light. Okay, so that's kind of a little safety consideration. The second thing that you need to bear in mind here is that you don't want to put too much sample onto the plate when you're spotting it at this point. What happens if you load too much sample on this is when we develop this, which we'll talk about in a moment, you tend to see streaking. And if you get streaking, that means you're going to have to redo this. So it's kind of a fine line. You don't want this to be dim, but you don't want to go overboard and put too much on here. It's no big deal if you put too much. You'll see streaking, and then you do it over again. These don't take very long once you get used to doing them. Before you do any of this, it's also probably not a bad idea to examine the edges of the TLC plate. Remember I talked about when we cut these things, you want to avoid disturbing the silica gel. So if the silica gel looks really disturbed, lots of little cracks on one side, you might want to use another plate. And I'll talk about what happens if the sides are not well cut in the next topic. I'll conclude now with developing the TLC plate. And to do that, the first thing we're going to do is obtain a jar. Make sure I make this big enough. And there are probably at least a dozen of these in the laboratory to do this. They're tall glass jars, just a little bit taller than the TLC plate itself. And the bottom, unfortunately, is often a little bit convex, bowed upward, which is unfortunate, so we'll talk about that in just a moment. The first thing you'll do when you obtain the jar, if it's not already in there, you're going to put a piece of round filter paper around the sides of the jar. Not all the way around, it should only extend about maybe half to 2/3 of the way around. And the reason for that is, well, let me put the TLC plate in first. So you're going to fill, once the filter paper is in there, you're going to fill the base of the jar with solvent, or add solvent, and the level of solvent has to be above the highest part of the glass, so that there's solvent above all the glass at the base of the jar. Then we add the TLC plate. And the easiest way to do that, I found, is with a pair of tweezers. So here's our TLC plate. And we'll say that we have 2 spots on this one, so there they are. So note, the bottom of the TLC plate is bathed in solvent. The level of solvent, remember, critically is beneath the 2 spots. Remember that if the solvent actually reaches the 2 spots, then your compound will dissolve into the solvent and contaminate it and ruin the analysis. If that happens, you've got to start all over again, remove the solvent, clean the jar, and add fresh solvent, and make sure the next time that the solvent doesn't reach the spots. So that's critical. And that's the problem with these convex surfaces in the base of these jars, because the level, of course, is not the same throughout. So I try to place the TLC plate right on the summit of the little hill there. The problem is, if you're not careful, it can slide off into a deeper part of the jar, and that can cause the solvent to reach the spot. So be careful when you place the plate. The easiest way to do that, I found, is with a pair of tweezers, like so. So gently put the plate into the jar with a pair of tweezers. Once you've done that, let's get rid of the tweezers. You are going to place a lid, screw the lid on the top of the jar. So these are screw top jars. So there's our lid. And that, of course, prevents the solvent vapors from escaping out into the laboratory. So at this point, you're developing the TLC plate, and the solvent is going up the plate. It's traveling up the plate like so. It's important to keep an eye on it. This can take several minutes, up to about 5 or 10 minutes sometimes. The rate with which the solvent travels at the plate depends on the solvent system that you're using. So the reason it's important to pay attention to that is you never want the solvent to reach the top of the plate. You always stop the solvent. You always take the plate out of the jar when the solvent reaches a certain point. And I like to give myself about 2 or 3 millimeters from the top of the plate. So I'll put a little line there. When the solvent reaches about that position, it's time to take the plate out. The reason why you don't want the solvent to reach the top is because it's not reproducible then. Because if the solvent reaches the top, what happens is that the solvent tends to just continue to evaporate off the plate, and it continues to run up, and that causes the spots to continue to rise up the plate, and so you don't really know reproducibly where the spots would be if you don't stop the solvent at the same place each time. So that's why you have to keep an eye on this. Don't let the solvent reach the top of the plate. So once it gets to this point, actually let me talk about one problem that might occur, that you might see as you're developing this, and this is another reason why you have to keep an eye on this. Remember, I talked previously about what might happen, why it's bad to disturb the silica gel on the sides of the TLC plate. If you see lots of little cracks, I call that feathering. That tends to cause the solvent to rise up one side faster than the other side, and so as the solvent advances up the plate, you start to see the solvent front go kind of sideways like this. And the problem with that is that pushes the spots off in this direction, which again is not particularly reproducible. So you'll end up with the spots over on one side of the TLC plate. So if you start seeing the solvent widely off center, or going up one side faster than the other side, it's probably a good idea to restart the experiment. Just go spot another plate. Be careful not to disturb the silica gel when you cut that plate, so that doesn't happen again. So hopefully you won't see that. So you want to, one other thing that you might see is if both sides are disturbed, you might see the solvent front go up kind of like this. And so it might travel up the sides faster than it travels up the center, and that can kind of move the spots to one side or the other as well. So that's also a situation you want to avoid. If you see that, again, you might want to redo it. Probably be a good idea to do that. So once the solvent has reached your close to the top of the plate, 2 to 3 millimeters is what I do, and you want to be consistent so that it's reproducible. We're going to take this out with a pair of tweezers again. So we take the lid off, take our tweezers. Do I really need to do that? I'll go ahead and do that. So we put our tweezers in and pull this out. And so let me redraw the plate. I'll kind of expand it here. So here's the expanded plate. So the pencil marks that you use to spot them are not going to move, so they'll be down here. And the first thing I do is with a pencil, I'm going to draw a little line where the solvent front reached, because that's important, as we'll see in a moment. So I draw a little line across there, and that's where the solvent got to right before I took the plate out. And then you let the solvent evaporate, and then pretty quickly after you've done that, you're going to take your UV lamp again with short wavelength UV, and you shine the UV light. Again, remember not to look at the UV. It's bad for your eyes. And if your compounds are conjugated, that is, they absorb light in the range of about 200 nanometers or more, you're going to see those compounds will fluoresce on the TLC plate. These TLC plates have a fluorescent backing that causes the spots to show up when you shine UV light on them if they're UV active. So what you'll see then are the spots. And so let's say that compound A ends up there, and then compound B ends up here. So this would be good separation between the two spots. So immediately once you see those, you're going to take a pencil and circle them. Okay, and you want to do this fairly quickly after you take the TLC plate out of the jar, because sometimes these compounds might be volatile. If they're volatile, these spots are going to disappear if you let this TLC plate sit for too long, so do this fairly quickly. So now that you've done this, you've got your fully developed plate, and you're ready to record your results in your laboratory notebook. Another possible problem you might have run into here, I think I mentioned earlier, is if you put too much compound on the TLC plate when you spotted it, that is, you tapped it with the capillary too many times, you might see streaking, and this is kind of what streaking looks like. And that can go all the way down. If you see streaking like this, it's a good idea to do it over again. What this usually means is that you added too much compound. So when you do it over again, don't spot the plate as many times with your capillary tube. So now for some last important considerations. First, recall, I think I mentioned this, that silica gel, which is the most common stationary phase for TLC, alumina being the second most common, both of them separate on the basis of polarity. So that means that more polar compounds, let me write that down, so silica gel separates by polarity. So that means that more polar compounds adhere to the silica more than less polar compounds do. So less polar compounds will move higher under the same condition. So this would be the less polar two compounds. And this one would be more polar. So really polar compounds often won't move at all. Very nonpolar compounds can move with a solvent front. depending on the solvent system that you use. So that's one thing to understand. And another really important parameter here is the solvent system itself. So the first thing I'll mention about that is that the ideal solvent will separate all the compounds in the lower about 2/3 of the TLC plate, so in this area down here. So the ideal solvent system, it's often more than one solvent. Okay, we're running out of space there. So this would be a very good solvent system, whatever you use for these two spots here. As far as the solvent goes, in my experience, most small organic compounds are separated adequately with mixtures of hexane and ethyl acetate. So that tends to work really, really well with silica gel chromatography. And so, of course, hexanes being a hydrocarbon or nonpolar, ethyl acetate being a carbonyl compound is more polar. And so you adjust the ratio of those two solvents to give you the best separation. Remember, aiming for this ideal right here. So now this is really critical, and this is a little bit counterintuitive. More polar solvents or solvent systems move all spots, all compounds, higher, even the nonpolar ones. So let's say if I know nothing about the polarity of the compounds or the compounds that I'm separating, I usually start off with about a 4-to-1 mixture of hexane and ethyl acetate. So let's say that these two spots were 4-to-1 hexane to ethyl acetate. Could be hexanes, a mixture of C6 hydrocarbons. ETOAC for ethyl acetate. So it's the same for that. So let's say that we used, instead of 4-to-1 hexane ethyl acetate, maybe 50-50. So how would the results be different? In that case, as we mentioned here, both of the spots will move higher up the TLC plate. So we'd see a situation like this, where again, this would be 1-to-1 hexane or hexanes to ethyl acetate. And so with that one, so that's the difference. More polar solvent systems, and this is more polar than 4-to-1, move all the spots higher, even the nonpolar ones. So more polar solvents interact more strongly with all the compounds, all the organic compounds on a TLC plate. So that's really important to understand. So remember, you're going to be playing around with solvent systems that give you this ideal here, that separate all your compounds ideally in the bottom 2/3 of the TLC plate. It's really, really critical that when you're reporting your TLC results in your laboratory notebook or in a lab report, that you include the solvent system, because if you don't do that, somebody can't go back and redo your TLC reproducibly. Okay, so that is absolutely critical. You lose lots of points if you forget to write down the solvent system that you use to do a TLC. So continuing with the theme of reporting your results, how do you do that, your TLC results? What I like to do, and this of course is expanded, what I like to do in my laboratory notebook is to draw just a scale representation of the TLC with where I spotted it, the little spots that I put with my pencils where the solvent front reached and where the spots are. And really that's all the information that you need. Another way of doing that, oh yeah, and of course critically, there's one more piece of information, the solvent system. So with that, that's one way of recording your TLC results. Another way is by using something known as RF. So for RF, so what is RF? RF is defined as the distance traveled by the center of the spot. That's right here. And so that's from where we spotted the TLC plate. So this is, we'll say this is D1. Over the distance traveled by the solvent front. So that's from where you spotted the plate again all the way up to that right there that you marked with a pencil. So this is D2. D2. So you can report RF, which is reproducible, as long as you remember to record your solvent system. And with that, I think you're now ready to do your TLC laboratory experiment and take TLC plates or TLCs for any reaction that you're going to be doing in the future. So I will see you in lab.